Howdy! In this video, we're going to look at even and odd functions. What are they? What does that mean? What do their graphs look like? And what's true about them algebraically? First, we're going to look at even functions, then we'll look at odd functions, and then we'll look at a couple of different examples on the calculator. All right, so we're going to start with even functions here. So if a function f satisfies this little statement right here, let's write this down. F of negative x is equal to f of x. What does that mean, right? If f of a negative number equals the same as f of the positive number, right? For every fx in the domain, then we say f is an even function. I'm just going to write f is even, okay? So here's an example of one. F of x equals to x squared, right? So here's a random x, and you can see the y value is, right here. There's f of x. The negative of x is the negative of whatever that number is. Well, it's going to have the same y value. Okay, so that means its graph is really just symmetric about that y-axis. This y-axis serves as like a mirror line. You can flip the graph over it and it lands on top of itself. So the graph of an even function is symmetric about the y-axis. Okay, so that's what's defined as an even function in math. Okay, and there's reasons behind the words even and odd that don't really matter for this video or for this level. This is intended for an algebra or a pre-calculus class right here. Okay, so let's next look at odd. What is an odd function? An odd function is a little bit different. You can see from the graph here, it's not symmetric about the y-axis or the x-axis, right? If you flip it down, you don't get the same function, right? So it's a little different. It satisfies this statement. If the function f satisfies f of negative x is equal to the negative of f of x for every x in its domain, then we say f is odd. Why? All right. What does that mean, right? Graphically, okay? There's a way to say it, the way we usually say it is it's symmetric about the origin, okay? There's two ways to really think about that conceptually or graphically in your head. So we have this right part of the function. I'm going to highlight that right there, right? The green part right there. Now, to say it is symmetric about the origin, what does that mean? One way to think about that is that you take that right half that I just kind of overlaid in green and you literally rotate it 180 degrees and see it lands on top of itself. Okay, so that is one way to think about it. Here's another way to think about it is you take that function here and you flip it twice. You reflect it, if you reflect that green line there, over the y-axis, you would get something like this. And then if I reflect that down, I would get something like that, exactly back on the function itself. My drawing is not very precise, but you reflect it twice, both over the x and the y. Order would not matter there, just one and then the other. Okay, so those are two different ways of thinking about reflections about the origin. And if that's the case, we call it odd. Now, it's important that you understand it both graphically and algebraically, okay? So here's another diagram here. I like this one. The graph of an even function, it's symmetric with respect to the y-axis. This is another random even function, but you can see that y-axis is a mirror line. And here's another odd one, right? You take this right half, rotate it around, and you get exactly that. Rotate it about this point right here. Like break the function off right there and rotate it, okay? So that one is odd. All right. Next, let's look at this both algebraically first and then on the calculator. So to determine whether the function is even, odd, or neither. So first we are going to do them algebraically. So if f of x is equal to x to the fifth plus x, we could, for both of them, what we're going to do is take f of negative x because on the definition up here, right, it is odd if f of negative x is equal to the negative of f of x. In a way, it's like the negative comes out. Not exactly, but that's what it's pretty much saying. Okay, and then it's even if f of negative x is equal to f of x. So for both of those, to determine if it's even or odd, we need f of negative x. So regardless of which one you're trying to determine, whether it's even or odd, the steps are the same. Plug in negative x. That is the step algebraically for all of these. Plug in negative x and we'll see what we get. Okay, if I plug in negative x, I am replacing each of these x's right here, that x and this x, by negative x. Now we need to put it in parentheses. So we have negative x to the fifth plus negative x. Well, a negative times itself 5 times is going to be negative. So that is negative x to the fifth. And then plus negative x is the same as minus x. Now, here's the secret. We want to try and factor out a negative. So after you plug in negative x, see if you can then factor out a negative. That's a question. Can you factor out a negative? Okay. Well, let's see. If I take a negative out, that would give me, make a little more room here. That would give me the negative of x to the fifth plus x. Well, x to the fifth plus x, that is exactly the original function, right? So in this case, we end up getting the negative of f of x, right? It's the negative of the original function. So we, in essence, just showed that f of negative x is equal to negative of f of x, which was the definition of an odd function. That is an odd function, okay? So let's go look at that on the calculator here, okay? So here, let's make that a little smaller. There we go. Okay, so here's a TI, and I just went ahead and typed them in beforehand, but we're only looking at this graph. Notice that equal sign is the only one highlighted, so that's the only one it's going to show when I hit this graph button. Okay, to get to there, by the way, I went to y equals, hit that y equals button. Okay, then we hit graph, and there it is, right? So there's the graph of x to the fifth plus x, and you can clearly see that it does appear to be symmetric about the origin, okay? So, all right, there is the first one here, and let's go try another one. Let's try g of x equals 1 minus x to the fourth, and I want you to pause the video and try this on your own first, okay? So what I want you to do is, there we go, is same two steps. Plug in negative x and then attempt to factor out a negative, okay? So what does that look like? Well, let's find out. Okay, so if we plug in negative x, I'm going to take g of negative x. Well, g of x is equal to 1 minus x to the fourth. So that would be 1 minus negative x to the power of 4. Okay, well, a negative to the fourth power becomes positive. So that becomes 1 minus positive x to the fourth. Well, look at that. That is exactly what we started with. G of x is 1 minus x to the fourth. So we literally just showed that g of negative x is equal to the original function g of x. And that, you might remember, is the definition of an even function. So this function here is even. And let's go look at its graph on the calculator. So we have g of x is 1 minus x to the fourth. So what I'm going to do is go back to y equals, and I'm going to hover over the highlighted thing there, hit enter so that it does not graph that one. I do want to graph this one, 1 minus x to the fourth. Say graph, and there you see it. You can tell that it is definitely symmetric about that y-axis right there. All right, so there's an even function. So we have an odd one and an even one. We figured out first the answer through algebra, and then we figured out, okay, that the graph does match what we got algebraically. Okay, last we have one more, h of x equals 2x minus x squared. Okay, so for this one, we're again going to plug in negative x. So h of negative x would be 2 times negative x minus negative x all squared. So that's 2 times negative x is negative 2x. Now, this negative x in parentheses squared does become positive x. So we have the negative of positive x. Okay, so far it's not clear what the answer is, right? But if we factor out a negative, that second step, factor out a negative, we end up with the negative of 2x plus x squared. Well, that's not equal to the original function, right? The original function is 2x minus x squared. This has a plus. And whether we do or don't factor out a negative, either way, we don't get the negative of the original function and we don't get the original function. So this is not equal to anything. So this one is neither even or odd. Okay, and let's look at its graph. So this is 2x minus x squared. We're going to go back to y equals. Going to arrow over, down. Oops, nope, nope, nope. Don't want to graph that one. There we go. Down, hit enter, down, hit enter. Okay, we're going to graph that one. Hit graph. Yeah, that one's really not symmetric about the origin or the y-axis. You could take this right half and rotate it, and you would not get what you see over here, right? That would look completely different. So that one does, the graph does match with the algebra that we got, which is that that one is neither even or odd. And just to kind of clearly show you what I was trying to say, if you take this right piece right here and I rotate that around, I would get something like, gosh, that's hard to draw, right? But like that. Right. It would be definitely not what we see there, okay? All right, so that's it for this even and odd functions, and I'll see you next time.